Fiber's in-house capabilities are mainly the design, development of turbo machines and using lightweight components as carbon fiber.
When we have a new idea or when we get a customer request, we start with an analytic calculation. We try to find out what physics is behind the task. We put it into a calculation and we come out with some results. We put things into a calculation table which tells us at the end what mass flow can we expect, what power input, what RPM do we need, what diameter. So we have a very good idea of how the product could look like.
Having all this capability in-house, I think we have the possibility to go a step back and see if everything is matching.
Let's talk a little bit about the details of CFD. CFD gives us the ability to predict the machine and to optimize it. CFD works in a way that you take a defined volume of air, you discretize it in a few million cells, and when you know what you are doing, when you have matched this simulation setup before to realistic or reality results, then you end up with results which you can trust. You can see every incoming flow angle at every portion of the blade, rotor and stator. You can see the pressure distribution, you can see tiny separations, and you can see the global parameters like mass flow, torque, RPM, pressure ratio, and it also predicts efficiency quite well. In 2014-15 we started to bring engineering capabilities for motors in-house, and that is called CEM, Computational Electromagnetic Design. So we slice the motor and we look into this slice and we can run magnetic optimization. This optimization tells us if we have magnetic flux passes which are oversaturated or undersaturated, so the machine gets too heavy. It tells us the really important thing of where we can destroy a magnet under temperature and high currents, so we can make the machine very safe against it. Last but not least, we need to have a close look into the strength and the robustness and safety of all parts, and for that we use various FEA codes.
FEA, we have a similar workflow as in CFD, of course. We start with the meshing. FEA process is quite similar to the CFD process. We start with a model that maybe a little bit simplified, and then we make the mesh. Then defining the boundary condition, it's quite tricky because we have rotating parts and we want to keep it as simple as possible to have the possibility to calculate it, to not make it too complicated.
After an FEA calculation, we know where a part could break, we know how to reshape it. We can also run it through an optimization, and we come up with, for example, with a blade design which is really safe and robust in the real world.